One of the determinants of the external validity of a research finding is our understanding of how the size of the treatment effect depends on the properties of both the population, so the people that you're dealing with, and also the situation, i.e. the context in which the treatment is administered. And there's a study on the topic that we discussed in the first clip, i.e. choice overload, by Scheibehen et al. And they pulled together 50 studies studying this treatment effect, and then they find that the effect is all over the place. So it can be either that reducing the choice set can increase consumption, as in Iyengar and Lepper, the GEM experiment. So the GEM experiment is probably far out there at the top, but it can also decrease consumption, but it can also have no effect. And they look at all kinds of moderators that they can think up, but then they conclude basically we have no idea. We don't know. We don't know what moderates the effect size here. Obviously, given that finding, that drastically lowers the external validity of any of those studies, because it seems like it's pretty much random. There is some random actually. Randomness here. You should not forget that there's also noise affecting effect size, right? And that is a direct function of sample size and power. But rather than noise, there's also, we cannot pick up any signal from the noise here. Even though we have 50 studies, it seems pretty much random what the effect size is. And that is not uncommon for work in the social sciences. Look, we are talking about treatments all the time, right? And that is a term from the medical sciences, and we are talking about treatment effects, and that suggests that we have a clear idea of whether a treatment works, and we implicitly assume then it's going to work everywhere and all kinds of and later on and for other populations. But the trouble is that when you're in the medical sciences, then for example you're looking at the effect of a specific drug, then one major advantage is that the effect of the drug can be assumed to be roughly similar across persons, because we all share a common biochemistry and a physiology. Whereas in the social sciences, how the treatment works is affected by the context, and this context can be greatly different. So certain channels may be closed off, or moderators may be completely different in one location compared to another location. So the way that society is organized moderates the effect of a treatment, and given the great variation in the way society is organized from place to place and also from time to time, it's very difficult to get high external validity in the social sciences. Let me make a link between what we are now discussing this week and what we discussed earlier on. So the late in Econometrics 1, and hopefully if you did not follow Econometrics 1, you're already familiar with the local average treatment effect. And remember, if we estimated a late, then the question is always, does the estimated treatment effect also hold for other populations? So for example, in an instrumental variable design, your identification is based on compliers, i.e. those subjects whose behavior is affected by the value that your instrumental variable takes on. And this population of compliers may well be different from non-compliers in ways that affect treatment effect. Yeah, that is basically a question about external validity. We did not call it external validity back then, but hopefully you see now that we were basically addressing the same question, that are the compliers and the non-compliers different in ways that affect the size of the treatment effect. And not only in instrumental variable designs, but also in regression discontinuity designs do we estimate a local average treatment effect. And because in RD designs the effect is related to subjects around the threshold, remember. And one example that we then discussed is using distance between your home and university as an instrumental variable for attending the lectures. And we want to have as good as random variation in attendance to estimate its effect on the course grade. And then obviously the question is, okay, the compliers, so those students whose attendance is affected by distance to the university, are those students different from always takers, so those who always attend the lectures, and never takers, those who never attend the lectures? I believe that was actually an exam question. And there's a good chance that yes, that those are different students, and for example, never takers may be students who know it all, and actually forcing them to attend the lecture after all may have no effect on their course grade. Unlikely, but who knows? Similarly, so that was actually the instrumental variable design, but in a regression discontinuity design, then the question is always, okay, is the effect only local around the threshold, or does it also hold further away from the threshold? Now, we already know how to get a better understanding of how the characteristics of population and place affect the treatment effect, because that's basically analysis of treatment heterogeneity. And you can either do that in your own study by interacting the treatment effect with moderators. Often you are greatly limited because you simply lack power. If you have only one study, and your sample size is usually fairly limited, so you may be able to look at one or two moderators, but not more. Ideally, you actually conduct an experiment in another setting. For example, you do it at another school or at another welfare office and see whether your results are comparable and whether there's more between your results than just noise. And a last step is to actually bring together all of the studies in the field and see, as Scheibenheine did, whether we can actually explain the different treatment effects, differences in treatment effects. And later on we also discussed that how to get a better idea of the mechanisms that are at work, and obviously that may also greatly help to understand why treatment works differently in different settings and for different subjects and in different times. Now the interesting thing was on the topic of choice overload is that there's actually a new meta study, and they have doubled the number of studies that they look into, and actually they do find a very clear pattern in treatment heterogeneity. So they also collect all the treatment effects, and then they know certain characteristics of each experiment, and they actually find basically that there are a couple of factors that increase cognitive effort that is necessary to make a choice out of many alternatives. And one of the things is that decision task difficulty. So if you want to make a choice within a couple of seconds and then you are exposed to 24 different jams, yeah, that doesn't help, right? Then you're like, well, I'll look at it later on. So that's one thing. Choice set complexity is another one. So, for example, how similar are the articles, etc. So, and they actually also referred back to the earlier meta-analysis, saying we document that when moderating variables are taken into account, the overall effect of assortment size on choice overload is significant, a finding counter to the data reported by prior meta-analytic research. And so indeed, choice, expanding the choice set can lead to lower sales under certain circumstances, but it can also have a different effect.